What?
Hi.
Good morning.
Morning. How are you?
Very well, and you?
I'm good, thank you. How's your morning so far?
A bit busy, a couple of problems, but so far not bad. And yours?
Oh, at 6 o'clock, my one educator told me she can't do her lesson and didn't send me slides, so I had to prepare and present. But it was okay. It went off well.
As long as it worked out.
Yes, it did. Thank you. Shall I share my screen?
Yes, please.
Okay. Okay, you'll tell me when to begin, right?
Definitely yes, but so far everything looks good. I'm just going to finalize everything on my side, but I'll give you the go ahead just before we start.
Okay. If I want to go back a slide, how do I do that? Because every time I click, it's just going to the next slide.
Try one of the back arrow keys.
Oh, that's clever. Okay.
Okay.
Thanks.
All right. I'll speak to you again shortly.
Okay, thank you.
Thank you.
Good morning, everybody. Welcome to main lesson. I wrote the wrong date on my lesson. Shoot. Good morning, everybody. Welcome to Grade 8 Natural Science. It's Arifa Hafichi taking you through the viewing of the eggshell experiment that I asked you to conduct during the long weekend. Then I have prepared a matter and materials glossary for you, which I would like you to download later on, which I need you to learn very well, because in the examinations, they do ask you for definitions, so you need to know this terminology. It'll also help you to learn, understand concepts better as you go along grade 8. And then I'm going to introduce you to friction and static electricity and explain how that works and what it is about. So a quick recap on last week's lesson. So we discussed that during chemical reactions, materials are changed into new materials when with new chemicals and physical properties. That basically means that during a chemical reaction, you have materials, you have your reactants and you have your product. So these materials, they become a new, they change its state because of the reaction, and it becomes either takes on a chemical or a physical property. So then we also have, sorry about that, we also have the materials will start as reactants and they are the new materials. So the materials we start with are the reactants. So the reactants make up new materials when they react together, and these are called products. Now, during a chemical reaction, atoms are rearranged. So it's very important to know that when a chemical reaction occurs, the atoms are rearranged. Now, this requires that the chemical bonds in the reactants are broken and new bonds are formed. So important for you to note is that the chemical bonds in the reactants are broken. They're broken into new bonds and new bonds are formed. So when the new bonds are formed, it results in a product formation. Okay, and then I'll explain it to you again using the diagram on your left. And then fermentation is brewing is an example of a chemical reaction. So this is part of indigenous knowledge. Now, indigenous knowledge is knowledge that was from your own country. So fermentation in brewing is also a part of a chemical reaction. So one way of revising and learning is to writing everything down. So when you write things down, it goes into your long-term memory. And long-term memory means that it's easier for you to remember it, especially during exams. So after you write it, then you use the diagram that I have on your left. So this diagram on the left is like a mind map. So it basically puts all your thoughts together and it helps you understand. So after you write things down to remember, to make information go into your long-term memory store, then just to revise and recap, because remember that even though you're revising something, doesn't mean that you learned something, doesn't mean that you're going to remember it if you don't keep on revising. You have to keep on revising. So then you use the mind map to revise. So let's say you have chemical reactions. They occur when substances uh, um, react to form new substances. So the new substances are called products. Then the substances are also called reactants. And the products have different chemical properties to make reactants. Okay, so then we also know that in a chemical reaction, it involves the breaking of chemical bonds to form a new chemical bond. And this new chemical bond is basically called a product. So can you see how this long summary here that I put makes it so much easier for you to learn when you are revising? And then on this side, we have chemical reactions. They involve a rearrangement of atoms. So you have different chemical bonds. When a reaction occurs, the atoms are rearranged. And then we also say that you can use, for example, if they ask you, give an example of an indigenous process using a chemical reaction. So you're going to say a chemical reaction used in an indigenous process is fermentation. Okay, so what I did now is I basically taught you a technique of studying, but recapping what we did last week because you had the long weekend and I can refresh your memory as to what we did last week. Okay, so we're going to continue with the next slide. So recapping, how many of you did the chemical reaction? Did anybody do this experiment that I asked you to do to see how the eggshell experiment worked? I'm going to check in my chat. Okay, so no one because nobody has raised their hands. But then I'll explain to you what basically happened to get the egg to look like that. So after 4 or 5 days, I'm going to go through the questions, and then after the questions, I'm going to give you the answers. So after 4 or 5 days, what were your observations between the egg and the vinegar? So when you conduct an experiment, obviously you have to record your observations. And the reactants here is basically the egg and the vinegar. So when you scoop the egg out of the vinegar and you touched it, so after 4 or 5 days, you're going to basically, you probably have taken out the egg with a tablespoon and then you touched it. So what did you observe? So remember that initially I told you that you observe chemical reactions through your 5 senses. So touch, sense of hearing, sense of feeling. So what did you observe? What happened to or what did you see? What happened to the eggshell? If you rub the powdery coating of the egg and placed it in clean water, that means basically if you rubbed it after taking it out and you rinsed it, then what would the egg look like? And then what signs did you see that told you a chemical reaction had taken place? So before you had removed the egg from the bowl, you would have noticed some signs if you did the experiment. So you can record what were the signs for the reaction to have taken place. Okay, so let's look at the answers. We say after 4 or 5 days, there was a foamy brown layer floating on the vinegar. That means that on top, you would have noticed that a layer formed above the vinegar. And this layer was a foamy brown layer floating on the vinegar. Right. So before I go to the next answer, who knows what do you think this foamy brown layer would have been? Anybody like to answer? What do you think that this foamy brown layer would have been? Yes, Robert, I'll ask my host to unmute you.
Is it the dirt that was on the egg?
It was, say that again, sorry?
Is it the dirt that was on the egg?
It's the eggshell itself. That would have been the brown layer on top. Okay, okay, that's very well done, but Nanshlanshla, you had your hand up. I'll ask my host to unmute you. Nanshlanshla. Okay, so yes, Nanshlanshla. I can hear you.
Ma'am, I was gonna say the eggshell.
Yes, very good. Well done. Doesn't matter even if I repeated it. It's good to repeat it because when you repeat it, you basically internalize the information and you learn better. So I don't mind. Right. So when you scoop the egg out of vinegar and you touch the surface, what did it feel like? Does anyone want to give me an answer for that? Okay, so I will give you the answer. So the egg felt soft and wobbly. The shell disappeared because it had dissolved. So because it had dissolved, it formed a foamy brown layer. So this foamy brown layer is actually the shell that floated on the vinegar. And it places basically, it was replaced by a powdery coating. Okay, so you would have like if you feel powder, you know how powder feels. So it's replaced with a powdery coating. And if you rub the powdery coating of the egg and you place it in clean water, so that means if you rinsed it, what would have happened? So you would say that the eggshell had lost its shell and you could see the egg white and the egg yolk. So basically, it looks like a oval-shaped rubber ball. So you could see, and it actually feels like an oval-shaped rubber soft ball. So you can see the egg white, and then you can see the egg yellow in the center. So the signs of the chemical that reaction that had taken place, so you would have noticed that the eggs looked different. So because the egg looked different, this is a sign to show you that the chemical reaction had taken place. So you probably saw bubbles as well. So if you did the experiment over the few days, you would have seen that bubbles formed on the in the vinegar, right? And thereafter, a foamy, scummy layer floating on top of the vinegar. So that foamy, scummy layer floating is basically the brown layer floating on the vinegar. Okay, so what I'm going to do today is I'm actually going to teach you how to write a summary of the experiment. Because in your exams, they're going to probably ask you, write a short paragraph to explain, or they could use the word to summarize what happened in the eggshell experiment. So your answer is going to look something like this, and I'll explain it to you as we're going along. So you're going to give important information. You're going to say that the eggshell reacted with vinegar and was eaten away. So the first thing you're going to tell them is that what reacted with what. So you say the eggshell reacted with vinegar, and then you're going to say it was eaten away. So this means by you saying it was eaten away, you say that the eggshell dissolved in the vinegar. So we say the eggshell dissolved in the vinegar. So the eggshell dissolved in the vinegar is saying it is eaten away. But you're using good terminology by using the word it dissolved in the vinegar. You're showing what has happened to the eggshell in the vinegar. So then you'll say the materials in the eggshell underwent a chemical change. Now, because we're doing chemical reaction, you have to tell them that the materials in the eggshell, it underwent a chemical change. And they have changed into different materials. That means now it has changed and a new product has formed. Even though it's still an egg, the way the egg looks is different. So it's a new product that has formed. So if we have to put it into basically reactants and products, then we're going to say the reactants were the vinegar and the eggshell. So the eggshell is called calcium carbonate, but if you don't put this word, it's fine, it's no problem, as long as you put the vinegar and the eggshell, and you say it reacts to produce the products. And the products are basically carbon dioxide gas. And why I say carbon dioxide gas is because in the previous slide, I told you that if you did the experiment, you would have noticed the bubbles forming, and that is the carbon dioxide gas. And then a solution is that brown foamy layer, which is called that calcium acetate. Okay, so you have your reactants, you tell them what it is, your vinegar and your eggshell, and you tell them its products, which is your carbon dioxide and your solution. So here you would get 1, 2, 3, 4, 5 marks. So this would be actually a 5-mark question. So you're telling them what reacted. You told them that the eggshell dissolved. You told them it underwent a chemical change. Then you told them it changed into a different material, and you wrote what the reactants were, and you wrote what the products were. So this would actually give you 5 marks. So to explain and to summarize basically means this is what you had to do for the eggshell experiment. Now, did you know that bones, teeth, and pearls will all dissolve in vinegar, just like the eggshell did, even though that it takes a much longer process. So you know that bones, teeth, and pearls, it will dissolve in vinegar. This is just an interesting did you know fact. Right. So what I did was I took the glossary for the matter and materials that we did in previous lessons, because we're now moving on to a new section. Okay, so all this that we've done from now and before, all the lessons that we've done was basically matter and materials. So after I show you what my email address is, you will see a glossary. So I'd like you to download this glossary and print it and learn these concepts well. Because when you learn the definitions well, when you're studying it, it gives you a better understanding of what to, it basically gives you a better understanding of all the concepts that you need, and it won't be so difficult for you to understand the lesson content as well, because you understand the terminology, you understand the definitions of the words, because it becomes very difficult for you to learn when you don't know what words mean. So when you study, also study a glossary, because it puts things into perspective for you. So I'd like you to do that at the end of the lesson. I'll also make it available for you on a worksheet, and we'll get our technical people to put it up for you during the course of the week. So we have friction and static electricity. So this is our new section that we're going to start with, which we'll be doing today and tomorrow. Friction and static electricity. So have you ever pushed a trolley through shops and you saw your hair and you heard it crackling? So you'd ask yourself, now what causes these shocks and what causes these noises? And sometimes when you're going up an escalator at a shopping mall and you just touch the a rubber, sometimes you just get a shock. Kayleen, I can see you've raised your hand. I'll ask my host to unmute you. Hi, Kayleen. Kayleen, can you hear me? I can't hear you. Okay, so we'll say these shocks and these that you experience basically is the effect of static electricity all around us. So basically, static electricity is all around us, but we don't always recognize it when we see or when we feel them. So we don't always recognize static electricity. So we don't see it, nor do we feel it. So, or perhaps you have, but you've never realized that it was static electricity or what was causing it. So what we're going to do today is that we're going to learn what causes static electricity. So you probably asked yourself, what does this have to do? I mean, the shocks that I feel, what does it have to do with electricity and friction, and how does it really work? Okay, so in grade 7, you learned that static electricity is caused by friction between objects, and that charged objects are either positively or negatively charged. So you learned that static electricity is caused by friction between objects, and they have charges, and these charges are either positive or negative. So basically, friction is caused by rubbing. So when you rub two things together, or you can even do it now, if you rub your two hands together, you're causing friction. And as you rub your hands together, you'll find that it gets a bit hot. So friction is by rubbing. So friction between certain materials, like for example, plastic or perspex or glass or nylon or wool or silk, it transfers electrons between the atoms of two materials being rubbed together. So basically with static electricity, there's a transfer of electrons between the atoms of two materials being rubbed together. So this is very important for you to know. With static electricity and friction, there's a transfer of electrons between the atoms of two materials being rubbed together. Okay, the electrons move from one material, causing a positive charge on its surface, and it causes a negative charge on the surface of the other material. So basically, we have a movement of electrons. So the electrons move from the positive charge on the surface, and it causes a negative charge on the other surface. Okay, now you must also know that only the electrons are transferred. The protons and the neutrons do not move. Okay, the protons and the neutrons do not move. Only the electrons are transferred. Now the protons and the neutrons do not move because it is embedded in the nuclei. Remember, I taught you about how the protons, electrons, and neutrons were arranged. So the protons and the neutrons are embedded together in a nuclei, and the electrons are free to move around in the atomic levels, the different levels. Okay, so we have objects or materials. They have the same, any object or any type of material, they have the same or like charges. So they have the same charges that repel each other. And then we can say opposite objects, objects or materials with opposite or unlike charges. Opposite means basically unlike charges. So it's opposite, unlike charges. They attract each other. So you know the famous saying that they say opposites attract. So even in objects and material, they opposite, unlike charges, they attract each other. So this is very important for you to know. So we'll say materials with like charges repel each other, and materials with unlike charges attract each other. I noticed one participant has raised her hand. Can my host unmute her? I think it was Azalea or Azalia. I can hear that you're speaking, but I can't hear your words.
May you please move slow, ma'am. You're going too fast.
Okay, so can I start this slide again?
Yes, ma'am, you may.
Okay, no
Thank
problem.
you.
Thank you for letting me know. Right, so we say friction. Friction is caused by rubbing rubbing two materials together. So examples of materials could be plastic, perspex, glass, nylon, wool, or silk. So basically, these rubbing of these materials together is a transfer of electrons between atoms of two materials being rubbed together. So I know that this information here that I've put on for you is difficult to understand, but then I don't want you, if you don't understand it fully right now, it's no problem, because all the other slides that I've put on for you basically explains this that I've written over here for you. But I will put it up for you so you know as I'm going to explain what I'm talking about, and it will put things into perspective for you. Okay. So the electrons move from one material, causing a positive charge on its surface, and it causes a negative charge on another surface. Okay, so I'm going to re-explain everything to you later on again. So I want you to know that only electrons are transferred, and the protons and the neutrons, they do not move. Now they do not move because it is in the nucleus, in the center of the atom. So important things for you to know is that materials with like charges means that they have the same charge, they repel each other. Okay, and materials with unlike charges, which are opposite charges, they attract each other. Now, a discharge of electrons causes a spark or a shock of static electricity. So now this discharge of electrons, They cause a shock, which is especially when the air is dry. Kayleen, you have a question. My host will unmute you. Hi,
Ma'am?
Kayleen.
Hello, ma'am. Ma'am, are you going to put the glossary at the end and will we be able to get it on Google?
Yes, I will put the glossary in the end for you. I've already prepared the slides for you. It is there.
Thank you, ma'am.
Okay. Right. So let's do an activity for me to explain everything that I've discussed over here. So it'll put things into perspective. So when you basically, if you take a balloon and if you hold it above your hair, you'll notice that nothing happens, right? But if you take the balloon and if you rub it against your hair and then you hold the balloon a short distance away from you, like in the picture that you have over here, then you will see that the hair particles are rising. Can you see his hair? So now we say that this is part of static electricity. So let's look at everyday examples of static electricity. Sometimes when you comb your hair with a plastic comb, your hair tends to stand on or it makes a crackling sound. So basically you're going to ask yourself, how does this happen and why does it happen? So you've dragged the surface of the plastic comb against the surface of your hair, and the two surfaces are rubbed together, and this causes friction between them. So friction is a resistance against the movement of an object as a result of contact with each other. So a friction is a resistance against a movement of an object, and it results when one object is in contact with another object. So this basically means that when you rubbed the plastic comb along your hair resisted the movement of the comb. So when you basically took the comb and you rubbed it along your hair resisted this movement and it slowed it down. So the friction between the surfaces can cause electrons to be transferred from one surface to another. Okay, so the friction between the surfaces cause the electrons to move from the comb to your hair, which cause the static electricity. And I'll explain it further in the next slide. Okay, so what did you notice when you put the hair with the balloon? You notice that your hair rises to the balloon. Okay. So in order to understand how electrons can be transferred, you must remember what we learned about the atom in matter and material. So you can see on the left the composition of the atom. So you have your protons and your electrons embedded in this nucleus, and you can protons and neutrons embedded in this nucleus, and then you see all your electrons, they're flying around. So the electrons is basically the things that move, that causes an imbalance to cause static electricity. So all the atoms have a nucleus which contains protons and neutrons. So you know that in any atom you have a proton, you have neutrons, and you have electrons. So the nucleus is held together by a very strong force, which means that the protons within the nucleus are considered to be fixed. So remember I explained in previous lessons that the electrons move in harmony with the protons. They don't just move randomly. They are in a fixed position. They move fixedly. So where are the electrons arranged in the atom? So you can see that we have layers. We call them as shells as well. So the electrons move around in their different shells. So I taught you that you have 3 and 4 layers of shells. So the atom is held together by an electrostatic attraction. So you're going to ask yourself, now what is she talking about now? What is electrostatic attraction? So we look at our definition here on the right. An electrostatic attraction is an attractive force which two unlike charges exert on each other. So it's an attractive force which two unlike charges exert on each other. when they are kept in a fixed distance apart. Okay, so we have two unlike charges. They exert on each other when it is in a distance apart. So coming back to our explanation, we say the atom is held together by the electrostatic attraction between the positively charged nucleus and a negatively charged electrons. So the atom is held together between a positively charged nucleus and a negatively charged electron within an atom. So the electrons closest to the nucleus are strongly held, while the ones that are further away have a weaker attraction. So now you can see when I put my cursor on the atom, so all these electrons that are right at the outer shell, these are the electrons that can move and cause static electricity because they have a weaker attraction to the nucleus and they move. Another word for it is it dispels. So we say that normally atoms contain the same number of protons and electrons. So we say in an atom, and I've taught this to you before, it has the same number of protons and electrons. Now this means that the atoms are normally neutral. So because it has the same number, the atoms are normally neutral because they have the same number of positive charges and it has the same number of negative charges. So the charges balance each other out. So in an atom, we say it has positive and negative charges and they balance each other out. That means that they are neutral because they, whatever, let's say if it has two protons, then it will have two electrons. So they balance each other out. However, when you rub surfaces together, like when you comb your hair or if you rub the balloon against your hair, the friction can cause electrons to be transferred from one object to another. So now this friction that I was talking about earlier, when you rub two things together, it causes a friction. Now this causes a transfer of electrons. So remember that the protons are fixed in the nucleus, so it cannot be transferred. Okay, it is only the electrons that are able to be transferred in another substance. So we know that only the electrons are transferred. So some objects give electrons more easier than other objects. So basically, you see your hair here in this diagram, and you see your comb. So initially, your hair and your comb, it was neutral. But when you start rubbing it against each other, then you'll see it has the charges start moving, and then one material, the comb either would lose electrons and your hair would gain electrons, and this is why your hair starts to stand. So when we talk about static electricity, we generally mean an imbalance between negative and positive charges. So that slide that I explained earlier on to you, it basically makes it a bit more clearer for you now. So we talk about an imbalance between negative and positive charges. Okay, so I'll explain it again here, but using the nucleus over here. When an object has more electrons than protons overall, we say it is negatively charged. Okay, and when an object has fewer electrons than protons, we say it is positively charged. So more electrons means it is negative charged, and fewer electrons means it is positively charged. So more electrons, negative charges, fewer electrons, positive charges. So have a look at the diagram. So you have these diagrams here. So there's 6 positive and 6 negative charges, so it's neutral. So here we have 6 positive charges and 6 negative charges, and we say it is, somebody has raised their hand, Tamio. I hope I'm saying your name correctly. I'll ask my host to unmute you. Yes? Hi. Hi, Tamio. Okay, so look, in this diagram, it had 6 positive charges and 6 negative charges, so there was a 0 overall charge. Yes, I can hear you in the background, but you weren't speaking. You want to try again? Hello? Hi? Hi? Okay, so we have 8 positive charges and 6 negative charges. Let me continue explaining the side and then I'll take the question again because Tamio, I heard him in the background, but he wasn't speaking. Okay, so 8 positive charges and 6 negative charges. So here we're saying it has less negative charges. That means fewer electrons. So we say that it is positively charged. So if we look at this diagram, it has 9 negative charges and 6 positive charges. That means it is negatively charged. So you understand the transfer of electrons that take place. So the electrons that are in the outer layers, that they basically moved, and they moved because of friction, friction that was caused. Yes, I'll ask my host to unmute one of the participants. Okay. Hi.
Hi, ma'am.
I can hear you.
Ma'am, this may seem like a stupid question, but I just want to know what is the difference between an atom and a molecule?
It's not a stupid question. It's actually a good question. And a molecule is made up of a few atoms together. That's the difference. Okay. It's a good question because no problem. In the test, they can ask you that question. What is the difference between an atom and a molecule? And then that would be your answer. Okay, so it's a very good question. You're welcome. Okay, so we have, but how did this result in your hair rising? So in the example of the balloon being attracted to your hair starts off neutral. However, the negatively charged electrons are brought closer. So remember I told you that the negative charge electrons in the outer layer, so it's brought closer and it leaves the more positive charges in your nearest to your hair. So the balloon is therefore attracted to your hair because opposite charges attract. So another example could be like dust settling on your new polished surfaces. It's because one has more charges than the other. Okay, so basically what we've learned is that negatively charged objects are brought close together and they repel each other. So it's very important for you to know that negatively charged objects are brought close together and they repel each other. And we have 2 positively charged objects are brought close together, they repel each other. Okay, and if positively charged objects are brought together, they attract each other. I think this sentence was repeated. So if a positively charged objects are brought together, they attract. When a positively charged object is brought near a negatively charged object, they attract each other. So important for you to remember in this concept of static electricity is basically like charges attract and opposite charges repel. Right, I'll take questions now. Does anybody want to ask me a question? Or you need clarity with something? So you can take down this YouTube site here, how static electricity works. So this would give you a visual learning experience. And sometimes when you learn through actually seeing something happening, you learn better. So this is a YouTube site that shows you how static electricity works. Okay, so our next lesson, what we're going to be talking about is sparks, shocks, and earthing. And I'm also going to do talk about electroscope, and then I'm going to just do the concept map. So remember how when I started this lesson, I did that concept map, that basically your mind map that explained what we did last week. So friction and static electricity I will finish tomorrow. So I'll do a concept map to show you how that works. And then I'm going to move on and start with electricity. Yes, that will be on Thursday. My host will unmute you. While he's unmuting you, I'll put my email address for you. So it's AHAFFE. Hi.
Ma'am, I would like to ask, can you please go back to the slides where you were talking about the positive and the negative sides?
Okay, what you need to know here, the most important thing that you need to know is this here. Like charges repel each other and opposite charges attract each other. That's the most important. So I'll show it to you in the slide quickly. So here, you see the nucleus, you have your positive charges in here.
Yes,
so here's your positive charges here, and here's your negative charges on the outside. So the ones that are on the outside basically are not so attracted to the charges with the positive in the nucleus. So they move when two things are rubbed together, when friction occurs. You know, we have a chemical reaction, so the friction causes your reaction.
Yes,
now this reaction causes the electrons to move. So I'll show it to you here. So when you're rubbing the comb against your hair, so the friction causes the electrons to move from your hair to the comb. So one becomes positively charged and the other becomes negatively charged. You understand that?
Yes,
So you
yes.
say there's an imbalance between a positive and a negative charge. That causes static electricity. Does that answer your question?
Yes, ma'am. Thank you, ma'am.
You're most welcome, no problem. Okay, so I promised, yes, I can't say your name. I'm so sorry about that, but my host will unmute you. I can try it, Rita Bailey.
Ma'am,
Yes,
can you hear me, ma'am?
I can hear you loud and clear.
Yes, ma'am. I just wanted to ask exactly what causes static electricity?
The transfer of electrons. So what causes static, oh gosh, no. What causes static electricity is the transfer of electrons from a positive, because of friction. So it causes an imbalance of electrons. So like charges attract each other and unlike charges repel each other. And because there's an imbalance of electrons, this is called static electricity, and it's caused by friction. Does that answer your question?
Yes, ma'am. Thank you, ma'am.
You're most welcome. Right, so I promised your glossary. So this is the glossary on matter of materials. And there's 1, 2, 3, 4 pages for you to learn. Okay, So you have the holiday to learn these. Most of these terms you will already know, but you can revise them and it will help you understand science better, especially math and materials, what we covered earlier on. It's been a pleasure tutoring you today. I hope you understood static electricity. We'll do a little recap on it so it makes it more clear for you tomorrow. And then we'll discuss the shocks and electroscope and the mind map before we proceed to electricity. Okay, I hope you have a lovely day and I'll see you here tomorrow again tomorrow. Goodbye, everybody.